Welcome to mathsmaster.org. We're going to have a look at the graph transformation y equals f of open bracket x add or subtract a close bracket of the function f of x. So the way this graph transformation works, or the way that I want you to think of it, is that we're taking a function of x and we're adding or subtracting the number, which I'm going to use the letter A to stand for. We're going to add or subtract a number to x before we then go and evaluate that in the function. So it's very important that you can see that as the add or subtract A is inside the brackets, that means that we are adding or subtracting that to x before we then go and evaluate that in the function. So we'll look at this graph transformation on two functions in particular. The first function of x is going to be x squared. So you can see here that I've put the x add or subtract a in brackets before I've then gone on and squared it to show that this graph transformation, the a is added or subtracted to the x before you then put it into the function. The second function that we'll be looking at is sine x. And when we apply this graph transformation, you can see that we'll be doing sine of, and then in brackets, x, add or subtract, a, close brackets. And again, I've put the brackets in there to show you that you'll add or subtract the a to the x before you then go and take the sine of that number. So let's start off by looking at how this graph transformation affects our function x squared. Okay, so you can see in the bottom left hand corner here that I've got the equation of the graph, which is our familiar y equals x squared graph, or in this case y equals open bracket x plus 0 close bracket squared. At the moment the value of a in our graph transformation is obviously 0, but you can see that I've got a slider which I can use to change the value of a. So let's have a look at what happens when I change the value of a. If I increase a, this is what happens to the graph. And if I subtract a, this is what happens to the graph. So if I add a to the function, the graph seems to be moving horizontally to the left, and if I subtract a from the function, so I've got open bracket x minus 3 close bracket all squared, the graph seems to be moving to the right from its original place. Okay, so this graph transformation translates the graph horizontally in the direction of the x-axis. And what catches a lot of people out with this graph transformation is that the graph seems to go the opposite way as to what you think it would. So people are familiar with the idea that it translates the graph horizontally along the x-axis, but they think if you had in the brackets of this equation x add 2, they'd expect it to move 2 to the right because that's the positive direction on the x-axis. And actually what happens is it does the opposite to that, it goes to the left. So if you are adding a number to the function, if you are adding, in this case we're adding 4, you need to get in your mind that if you add the number, that the graph moves left. And likewise, if you subtract the number, that the graph moves to the right. Okay. A actually tells us the size of the translation as well. So if you look at the very bottom of the graph here, where it passes through the origin, the point 0, 0, let's say we look at this graph now, which is open bracket x plus 4 close bracket all squared. You can see that the bottom of the graph is now at the coordinate minus 4, 0. So it's actually shifted by 4. So the size of A actually tells us how far we need to shift the graph as well. We need to shift it by A. Let's have a look now at the effect of this graph transformation on the original function of x, which is sine x. So here is the function y equals sine of open bracket x plus 0 close bracket, or at this stage obviously just y equals sine x. And similarly before, you can see I've got the equation shown here and another slider that allows me to change the value of a. Now exactly the same process works as before. The graph transformation is the same for any function of x. So if I slide this slider to the right and we're adding a value of a, you'll see that the graph is moving to the left by a value equal to a. And if we're subtracting an a from the function, you can see that the graph shifts by the value of a to the right. Now, sine x, y equals sine x, actually goes through the origin of the graph, the point 0, 0. Let's have a look at what happens if we look at this function now. Y is equal to sine of open bracket x add 90 close bracket. Well, what's happened is the graph has translated by a value of 90 to the left, and hopefully you can see that this is now become the cosine graph. This is now the graph of y equals cos x. So I think that shows a nice sort of illustration of a link between the functions sine x and cos x, and how you can actually change between them using this graph transformation. Okay, just to summarise, we've looked at the graph transformation of y equals f of open bracket x add or subtract a close bracket, and that graph transformation's effect on the function f of x when we plot it on a graph, and we found that it translates the graph horizontally. That's in the direction of the x-axis, but we have to be careful not to be caught out with which way the graph moves. If you add a, then the graph actually moves to the left, and if you subtract a, the graph translates to the right. That was the graph transformation y is equal to f of open bracket x add or subtract a close bracket of the function f of x. If you want to see some more great maths videos, please visit mathsmaster.org.